Welcome to one of the last talks of Google I/O. Thank you all for being here, even at this hour. My name is RJ, and
I'm Thomas Bolton.
I'm Abe Haskins.
we all work on Cloud Functions. What you have here is some of the best-looking Twitter handles in the team. So I created mine just for you a week ago, but if you want to follow a more experienced Cloud Functioners, you can follow Thomas or Abe. Especially Abe is great. We are here today, all three of us, to talk about Cloud Functions, about testing, and about open source. So you might wonder to yourself, RJ, why do we need to talk about this? Because I know how to test my code. I've been doing this for ages. I know everything there is to know about open source. Well, it turns out this is Silicon Valley, and we've gone and changed the world. And the world of serverless looks quite different from what we were familiar with before. So everything is different, right? Nothing we know applies anymore. We need an entirely new set of best practices. Well, not quite. There's a small snag, which is that best practices take practice. They take a lot of time to build. So this is not something that would just pop into existence in the, what is it, like 2 months since we launched Cloud Functions into beta. It is not even something that we could have experienced in the few years that we've been working on serverless. It is something that forms over literally decades. So we actually don't think that you should throw out the best practices that you know, that you love, that you're familiar with. But the old is the new. All you need is a new set of tools to apply what you already knew, the old best practices that you may already be familiar with, and then to apply those in the new world of serverless with a new set of tools. So what we want to do today is basically do 3 things. We want to bring you into a mindset that we think is conducive to writing good code. And then we would like to call out a few best practices that roll out of that mindset. And then we would like to give you a few concrete examples of how to apply those best practices in a world of Cloud Functions, in a world of serverless more generally. So let's dive into that mindset. This is what we call the open source mindset. And the open source mindset is interesting. It is good to look at because it's one of the most thorough mindsets that you can get into when you're developing code. Open source turns out to be a hard place to develop code. For example, other people might deploy your code. This is true whether you want it or not. Like, people can just take it and run it anywhere. You will have to assume, however, that even if other people help you out and contribute some code, they won't maintain it. So the code is your problem, whether you like it or not. You will also have to assume that the code will get reused, because this is something we've all done. We copy and paste. And most importantly, at least in my opinion, hopefully you're doing this for fun. And especially with open source, where you're doing this in your free time, it had better be fun, or you won't do it. Now, you may say to me, well, RJ, this is all well and good, but actually, I am, in a cushy job. I get paid to write code. None of this is actually relevant to me. Why am I here, other than for the nice air conditioning on a hot day? So we actually think that this mindset is useful no matter where you code or how you code. So, for example, if you are in a closed source environment, in some sort of company, say, the same rules are useful to you as well. For example, even though the number of people that deploy your code are fewer, you might deploy to a staging environment, 17 different development environments, as well as eventually production. Your code is most definitely your problem. People will call you on a weekend if it breaks. Even if somebody else breaks it, you're the person they know wrote the original bit of it, so you're going to get called. Reuse happens everywhere, not just in open source. Copy and pasting works at your workplace as well, if that's like a closed source company. And most importantly, again, at least in my opinion, hopefully your job is fun. So with that in mind, I hope to convince you through this talk that the stuff we tell you, even though it comes from a mindset of open source, it is actually useful no matter how you code or where you code. With that, let's dive into that first assumption, the assumption that other people deploy your code. So from that rolls a best practice that we want to share with you, which is that you should put your configuration in the environment. Don't put it in configuration files, especially don't hard code it into any of your code. Put it in, essentially, environment variables. This is not new advice. This is something that you may have heard from places like the 12-factor app. But we want to show you how to do it if you're developing in a serverless world. So let's take a look at Firebase hosting. Firebase hosting lets you host static files. That can be your HTML, your JavaScript. But if you are using something like the Firebase SDK, which I hope many of you will be using or else will get a chance to play with soon, then you need to configure that SDK. Because that SDK talks to a backend, which means you need things like an API key. And that API key is different between your production environment, your staging environment, everybody's dev environments. So how do you avoid hard coding your SDK's API key when these files have to be static? Well, the answer is here on the second line of code that you see there. You see a Firebase init.js. And that little snippet of code will initialize your Firebase SDK by pulling environment variables into your code and configuring your code that way. And we have been smart enough to set those environment variables for you, no matter where you are, either running locally using Firebase Serve or on the cloud when you've run Firebase Deploy. So this is super useful. If you now git clone this file and you git Firebase deploy it to a completely different project, it'll work. There's no code editing, no configuration editing, which means that it's super easy to switch between environments. Great, so this is useful. This, however, is the front end. Let's have a look at the back-end code, the Cloud Functions code. It's actually even easier there. This example imports the Firebase admin module into our Node.js environment. And same as with the client-side SDK, you have to initialize it. Well, you can do that by saying functions config Firebase. That pulls environment variables in. It'll initialize your admin SDK, and you're ready to go. Once again, I can deploy this to any Firebase project. It'll just work, which is great. Now, with that, I'd like to hand it over to Thomas. Oh, I'm sorry. I forgot one of my slides, and this is actually one that I'm very excited about. So sorry. It turns out there's, of course, cases where you want to put stuff in the environment, where you can't just rely on the environment variables that we set for you. And that is possible, too. So in this example, what I'm doing is I'm on my command line writing Firebase functions config set, and then I set some secret, some API key, some configuration value that I like. And it's there. It runs in my, it appears in my server-side environment. I can load it in the same way that I loaded the Firebase configuration environment. So it's super easy to access. It's great. If you are deploying a new project, you can clone your environment configuration from the one project to the other. You do that only when you're setting up the project. So you copy it across once. You edit whatever values need to be edited when you set up a new project. And now you have a new environment that your code can run in. So if you're developing code, I highly recommend that you think to yourself, can I just clone this exact code, deploy it somewhere else, and run it? That would be the goal. All right, with that, over to Thomas.
Thank you. Thanks, RJ. That was definitely worth covering in depth. It's one of my favorite features of the Cloud Functions SDK for Firebase. So, with a show of hands, how many of you have ever either released software or deployed to production? OK, that was about as many as I expected. How many of you were stressed when you did this? That's about 100%. So, this is actually one of the most nerve-wracking parts of our job. And I find it absolutely crazy how often we fight giving ourselves a basic safety net. And so there's an obvious piece of advice that you'll see all over the open source community. Add some tests. So, before we dive into how to test Cloud Functions specifically, I'm going to take a very quick detour on how you test JavaScript code generally, since that's what we use to write our Cloud Functions. These are the node modules that we're going to be using in our talk today, so if you want to take a quick picture, you can look them up a bit more later. So, here's a very simple unit test that tests the Fibonacci sequence. And we're using two different tools here. This part is Mocha. Mocha is a test runner. It lets you define your test suites with the define command and your test cases with the it command. You can also define callbacks that should be run before or after the whole test suite, or before or after every test case. Then Mocha will give you a test runner that will run all your tests and aggregate the results in a nice human-readable summary. The one thing Mocha doesn't do, however, is actually verify any behavior in your app. So for that, we're going to use a second tool, Chai. We like using Chai for two reasons. One, like Mocha, it helps you get very human-readable tests. It reads like English, so you can understand your tests as a contract for the expectations in your code. The other reason is that Chai is incredibly extensible. We're actually going to use an extension to Chai later on in this talk. Now, once you've written your tests, I highly recommend that you wire it up to your package.json. Package.json supports a scripts field at the top level of the file. And there's a well-known script called test. You want to do this, that way you can just run npm test. Because you may remember how your tests are run, but this is the industry standard way of grabbing a random node module and testing it. And if you conform to the industry standard, people know how to run your tests. And if they know how to run your tests, it's more likely that they actually will. So, back to our regular program, let's talk about Cloud Functions specifically. So, for many of you, this may be your release process. You followed RJ's advice. Your code can be deployed easily to a staging tier. Now you have a hacking party and try to break your app. And if you don't see anything, you'll roll out to production. I at least hope this is your plan and not just this part. So, if this is the way you release your app, if your needs are so complex that you need to do a full system test, I can still help you automate that middle step. Because it turns out the Firebase command line tools are actually a node module. You can include them in your code just like any other library. So now we're going to write a systems test that actually tests our staging environment for a live HTTP function. We'll use the before hook to actually deploy the current project to our staging tier. Next, we'll create an actual HTTP request that is targeting our staging tier. We can grab any off-the-shelf HTTP library and send a real live request to real live servers, and then verify the actual HTTP result. So this is a very powerful tool for the most complex of testing needs. But there are some downsides to this. Because obviously, if you're deploying to production and talking to an external server, it's going to take a lot longer for your tests. So you should save this technique as a last line of defense. Another drawback is if you're actually targeting the staging tier, you can't have multiple people in your team run your system-wide tests all at once. They're going to collide with each other. So let's try to make this a bit more advanced and go from a systems test to an integration test. Well, it turns out that just like the Firebase tools, the code you write with Cloud Functions is the library as well. You haven't written a whole binary. You can import it inside your tests. So here, we've actually imported an actual HTTP function from our Cloud Functions code. Now, you may not know this, but the thing you create with a Cloud Function is actually a callable function. You can call it yourself. So now, instead of creating a real live service and running a real live network request, we're going to use an extension to Chai called Chai HTTP. With this, we can give a network response handler, which your HTTP functions are. And it has created an in-memory web service. So now we can do true HTTP-level testing. Here we're doing a GET request with a query parameter against our actual Cloud Function, the whole function, and still verifying the result as an HTTP response body. Now, this is a great idea for integration tests. There is one small problem, though. If you followed RJ's advice, this is your index.js, at least the start of it. This line right here is the special magic RJ told you about. And as he said, it doesn't depend on your code. It depends on a special environment we create in production and the local emulator, which means that this is actually going to throw an exception if you run it in a unit test. But we can add another tool to our JavaScript tool belt and solve that problem. We're going to use sign-on. It's a very powerful tool for creating mocks, creating spies, and stubbing different implementations. So first, we're going to include the Firebase Functions library and then actually modify it. We can change the behavior so that functions.config no longer depends on this automatically created environment, and instead it returns a fake object. Now we can run our integration test. So as a quick aside, and some tips about these tools. Sign-on, or a similar library called knock, are really, really great for certain cases. I love using them to mock the system clock. In the Firebase Functions SDK, we have behavior that doesn't kick in for a minute or so. But by using sign-on, we can fast forward the system clock and test our behavior without waiting a minute in our unit tests. You can also use a spy to make sure that a callback gets called. And if you have a dependency on an external service, you can use knock to mock the entire network interface. What I just showed you isn't honestly the most powerful use of sign-on, though, because we created a side effect in index.js and then worked around it. It's kind of strange because if I created another test suite, I'm going to have to add that same boilerplate all over again. And if I add a new side effect in index.js, I'm going to have to modify all those test suites. And whenever you find yourself rewriting the same code over and over again, that should be a code smell. And you should try to think about how to approach it differently. And that brings us to our next mentality. Assume your code will get reused. If you see that code is being copied and pasted in your code base, if you break something and you find out you have to fix the same fix several places, there is a solution for that. Look at how you can make your code more modular. So let's rewrite our actual Cloud Function so that it's more easy to test without those side effects. I recommend that you treat your index.js like your main file. In traditional programming, people don't often test their main file. Instead, the main file is very simple boilerplate that composes very, very rigorously tested libraries. And so we can do that here as well. We're going to move the logic of our Fibonacci function into a library file and include it in index.js. Inside our Cloud Function, we'll call this mathematical version of the Fibonacci function. Now this mathematical version is incredibly easy to unit test. You don't even need to create an in-memory server, which will save you a lot of time in your unit tests. And then there's this bit right here. That seems very coupled to the fact that we're a Cloud Function. There's not a lot we can do. But you're probably going to write this over and over again in your other HTTP functions. So instead, just make that another library function. And this has a few benefits, because now you know that in your HTTP functions, you have a consistent rendering strategy. And this one library can be tested independently and reused. If this is your index.js, I wouldn't hold it against you if you didn't unit test this, because you can now have very focused tests for everything inside of it. So this leads me to a few other tips on how to create testable, complex backends. Try to make your index.js so simple that it has little to no conditions or loops. Next, try to make sure that you have no globals in any other file. If you need a global, make it a parameter in your utility method, initialize it in index.js, and pass it in. You will find that your libraries are dramatically easier to test. I even recommend this when you're doing things like the Firebase admin SDK. Don't say admin.database in your lib.js. Take that from index.js. Some other tips related to HTTP functions. In general, you should not be building libraries that are Cloud Function specific because you're going to have a harder time testing them. And if you have something that's innately coupled with the nature of HTTP, make a standalone library that you call within your Cloud Function. Now, here's a more complex example than Fibonacci. We have a Cloud Function that is an API for getting a user's order status. We obviously need to authenticate the user, but we don't need to do it in index.js. We can create a simple testable method. Because it makes sense that this is tied to HTTP. You might accept a session token based on cookies, headers, or query strings, but that doesn't mean it has to pollute your global code. Now that we have this nice isolated HTTP method, the rest of our business logic can be more abstract. Our get query order status takes an authenticated user, and we can continue from there. So I'd like to leave you with a few more tips on how to improve the quality of your code. First of all, you should always lean on industry standard methods or tools. Because when you import these libraries, you're not just importing the dev code, you're importing their unit tests. And the best way to improve your code quality is to write less of it. If you find that your code is getting more complex and adding too many edge cases, ask yourself how you can try to narrow down your scope and simplify your app. So with that, I'm going to hand it off to Abe to add a slightly personal touch to the talk.
All right. Thank you, Thomas. So far, we've been talking a lot about code. But this last section, this last assumption with the open source mindset is more of a philosophy and more of an idea about why you're writing code and building things in the first place. So we want to assume we're doing things for fun. And I think the best way to illustrate running a fun project is to talk about an actual project that I've been running for a couple of years. This project is called jpeg.cool. And jpeg.cool is the simplest service you could run. I started about 2 years ago, and it has a very simple functionality. If you put jpeg.cool/anything into your browser, it'll go and it'll find you an image or an animated GIF, and it'll return that to you. So for example, if you typed in jpeg.cool/Firebase logo, it'll get you back a Firebase logo, and it just returns that as an image. If you typed in jpeg.cool/Google logo, it'll get you back this really complicated animated GIF of the Google logo. It's not very consistent in what it returns, but it'll always get you something, and it's always kind of interesting. Here is some other interesting ideas. If you type in fire.gif, you'll get a nice, pretty Firebass from last year's I.O., or Firebase hot sauce. Try usernames, things like that. It'll just return some image. Sometimes it's related, sometimes it's not. But it's an interesting project. So with the open source mindset, over the 2 years I've been running jpeg.cool as a side project, I've got to learn the really applied version of this mindset. And I can go through each of these assumptions and see what they look like for me in a real application. So assumption 1, assume others deploy your code. With jpeg.cool, no one else has ever deployed the code. However, with the jpeg.cool mindset, I forget how to deploy my code. I don't remember Kubernetes commands very well. I don't remember how I SSH'd into this box 2 years ago to set this up. So I don't remember. So I need to make my deploy process optimized for that. Then I assume my code gets reused. The core code base of jpeg.cool hasn't changed in 2 years. However, how I deliver it to you has changed dramatically. In some cases, it was running on just a compute engine VM. It's ran on a Kubernetes cluster. It's now running entirely on Firebase Cloud Functions, or Google Cloud Functions for Firebase. This has moved around a bunch, but that code has stayed the same. So it's gotten reused a bunch of different ways. Then assume it's your problem. People ping me when jpeg.cool goes down. As a small service, most of the users of jpeg.cool are my friends or family, coworkers, people like that. And these people have no filter about bugging me when it goes down. I'll get calls and text messages and everything whenever it doesn't return an image. And that's very, very annoying. So if we assume I do this for fun, I'm not doing it for fun anymore. I'm sick of people pinging me. So we need to optimize for this. We have to come up with a situation where I can stop thinking about my pesky users, and I can just have fun having the code, thinking about the actual problem, and I can always be ahead of my users. So if something does break in production or there's some issue, I can be aware of it. So first, we need to be able to get code out quickly. This is step one. We need to make shipping jpeg.cool as easy as committing code. So no Kubernetes commands. We don't even want to think about Firebase deploy. I do this with jpeg.cool via service and continuous integration. Firebase has built-in continuous integration support, so you can generate a token and provide that to a service. If you're not familiar with continuous integration, this is the idea that you have some external service generally that knows how to deploy your code. You set up some rules and some guidelines, and it watches your Git or other repository. And when you make a change, it runs it, it tests it, and it ships it out to production. So in other words, once I've set this up, set up my Firebase deploy command in my continuous integration environment, I know that if I commit to master in the jpeg.cool repository, about a minute later, it'll be shipped to production, and that's all I have to remember. I'm not going to forget how to use Git. So this works really, really well when I'm responding to issues at 2 in the morning. This is part of a bigger narrative, though. We don't just want to ship fast. We want to debug fast. That helps reacting fast, but it doesn't really help us debug what's wrong with the application. If jpeg.cool doesn't serve up an image, it could be breaking in a bunch of different spots. So we need a way to have a new level of insight into our application while it's running in production. This is Stackdriver. If you're used to using Google Cloud or even parts of Firebase, you may have heard of Stackdriver. Stackdriver is Google Cloud's solution to dealing with any problems related to insight of your application. So if you want to know what's happening when your application is running in Google Cloud, you'll want to look at Stackdriver. And this is linked to in the Google Cloud console. It's not in the Firebase console, but if you go into the Google Cloud console, you'll see it in there. And just about every part of Google Cloud links out to Stackdriver in some way. Your App Engine app throws data off into Stackdriver. Every application and compute engine will log out to Stackdriver. It's really deeply integrated. So in terms of knowing what's happening, Stackdriver is where we're going to want to look. The first and easiest solution, or first easiest use of Stackdriver, is to let it enhance console.log for us. Obviously, console.log is the common denominator when we're building code. It'll print out in my terminal on my PC. It'll print out in a log to a log file on a server. So this is the de facto standard for knowing what's going on. And that's honestly kind of upsetting, because it's just a big stream of text. That's not that interesting. This is what it looks like. This is Stackdriver logging. So these are just console logs coming from my application. And you can see we have timestamps. We have the function. In this case, it's request cool or fulfill cool. And then we have these crazy IDs. And these crazy IDs are actually individual invocations. So if we click on one of those, Stackdriver logging will automatically create a filter that allows us to see the invocation, the life cycle of that one function call. So we're not looking at a bunch of sliced logs from different functions overwriting each other. We can step into one, and we can figure out exactly what's going on. In this case, I can read that and see that somebody typed in jpeg.cool/crickets, and they got back some image. So that one looks pretty good to me. However, this is just the beginning. This is console.log improved, but we can go farther than that. This is Stackdriver error reporting. And this is something that's built in when you deploy your Google Cloud Functions. This is a way to know anytime something throws an error in your functions. In this case, I have a few different errors that have risen up over time. Silly mistakes like ref.on is not a function or cannot read a property. But these bubble up and get caught by Stackdriver error reporting. If you want, you can configure this to send you a text message, alert you on the Google Cloud mobile app, different things like that. but it lets you know if something is breaking in production that you are aware of it. If we click on one of these, we get a graph of how often it's been happening, when it was last seen. We get the stack trace. We can step into individual occurrences of this issue. We really get a whole new level of insight without writing any code. You're not even importing an SDK into your JavaScript code. This is just the awesomeness that is the functions environment. This is a type of monitoring that is very simple. You're not doing anything, right? You're not importing special things. You're not importing an SDK. But we can go farther. We can actually build custom metrics around Stackdriver and all the data that Google Cloud throws into Stackdriver to get an even better idea of our service, to make sure we're confident that our service is up. Now, jpeg.cool has a bunch of functions, like I said. Here are the invocations of different functions. So here we see fulfill.cool, we see a test function called hello world being executed, and we have more down there that aren't shown. One of the most important ones here that is down on that list, because it doesn't get invoked very often, is the cache cleaner job. If you go, like me, and download random animated GIFs and things off the internet and throw them into a cloud storage bucket like jpeg.cool does, you're going to find that a lot of animated GIFs are really, really big, like 100 megabyte big, if you're just randomly grabbing them. And this is an issue if you're paying for the service like I am. So I don't want those in there. If no one's accessed this GIF in 2 weeks, but it's still taking up 100 megabytes of storage, I'm going to go clean that out. And so I do that as a cron-type job, a cloud function that just triggers every day, and it just cleans it out. The problem is, if that function fails, if there's something in there that makes it not succeed, it doesn't get invoked, something happens wrong with the cron process that's actually triggering it, I'm not going to know. It's just going to fail silently, and it won't ever be exposed to my users. So I set up a custom policy, the daily cache cleaner job policy. And all this does is watches invocations of that specific cache cleaning function and says if it ever doesn't get invoked for a given 24-hour period, something's wrong. Like if it doesn't get triggered, we need to know about it. So that's exactly what this does. This is a couple situations over the last 2 months or last few months where this job hasn't gotten invoked. It happened on April 5th, happened on March 21st. Just for whatever reason, my job didn't get invoked. And as soon as this happened, as soon as it started failing, it sent me a text message and said, hey, your cron job is not working anymore. Something's wrong. That's great, but that's really only half of the narrative here. Once this daily task cache cleaner job got back healthy, once it was healthy again, I got another text saying, hey, the situation has been resolved, your function is running well again, and everything's OK. So the combination of these checks, a couple other monitoring checks I have, uptime checks, just HTTP pings, things like that, all set up in Stackdriver monitoring, I can be incredibly confident that jpeg.cool is always up. And if something goes down, I'll know about it before any of my users. And with that, I'll hand it back to RJ for some closing comments. Thank you.
Thank you, Abe. All right, before we send you back into the heat, we thought we'd quickly recap a few of the higher level statements that we've made. And the first was that best practices take practice. So don't expect that in a world of cloud functions, of serverless, that we've been talking about, we will have to completely reinvent the wheel. We will keep using the best practices that we know and love. We just use new and maybe even better tools to use those in our new world. Secondly, we would argue that you should pay attention to how open source does development, even if you don't do open source development, because it helps you write better code that is more robust, more reusable, all that good stuff. We would like to invite you to meet us in the sandbox that is right outside here, the tent that says Firebase on it. We'll be there basically until I/O closes. If you have any comments, questions, remarks, find us there. We'd love to hear it. Here are some useful links in case you are curious. All of us work on cloud functions, and we would love for you to take a look at our documentation, play with it. Once again, let us know if you have any comments. And if you'd like to learn more about cloud functions, about Firebase, about the whole backend as a service, serverless world, you should check out our YouTube channel. That is youtube.com/Firebase. With that, thank you so much. Feel free to follow us on Twitter. Especially Abe is addicted. He is very entertaining. So I hope to see you all outside in our tent. And thank you so much for being here. See you next year.